everyone. Today we're going to simplify two sets of rational expressions through subtraction and addition. Okay. So for the first one, we notice that they all three have completely different denominators, right? And in order to subtract and add fractions together, we always need a common denominator. So for this one, we're going to have to do a bit of work. Each one is going to have to be multiplied by the other two denominators together as a product. So what that means is our first term is going to have to be multiplied by x minus 2 and x minus 3 in the numerator as well as in the denominator, okay? Now, the second term is going to have to be multiplied by the other two denominators. So we're going to multiply its numerator and denominator by x minus 1 times x minus 3, and again times x minus 1 times x minus 3. And you'll probably be able to guess that the third term needs to be multiplied by the other two denominators, namely by x minus 1 times x minus 2 in the numerator and the denominator alike. So now we are going to have a common denominator for all three terms, which means we can bunch up all the numerators into one fraction, into one term, right? But we're going to have to multiply through and simplify everything in those numerators all into one. So what we'll have is, from the first one, 1 times x minus 2 times x minus 3 gives us x squared minus 5x plus 6, right? Then we're going to do minus 2 times all that. So that'll be minus 2 times, if we expand x minus 1 times x minus 3, it'll be x squared minus 4x plus 3. And finally, we have plus 1 times x minus 1 times x minus 2, which means plus x squared minus 3x plus 2, like so, okay? And again, all of this is combined into one single numerator over a common denominator of, let's leave it in factored form, because we might be able to simplify later on as the product of x minus 1 and x minus 2 and x minus 3, okay? Now, let's clean up our numerator. So we have x squared minus 2x squared plus x squared. That's x squared minus 2x squared plus x squared for the x squared terms. Next, let's do the x terms. So we have minus 5x here. Minus 2 times negative 4x is plus 8x. And minus 3x, like so. And from the constant terms, we have plus 6. Minus 2 times 3 is minus 6. And in the end, plus 2. And again, all of these are over one common denominator, the product of x minus 1 and x minus 2 and x minus 3. And so now we're just about at the end. We just need to simplify our numerator. So in the x squares, x squared plus x squared minus 2x squares, those conveniently cancel each other out, right? Next, negative 5x minus 3x is negative 8x, plus 8x means the x's cancel each other out as well. And last, we have 6 minus 6, 0, plus 2. So all we have left is 2. And that is going to be all over that denominator of x minus 1 times x minus 2 times x minus 3. And that is what we would end up with. We could write down our NPVs, our non-permissible values would be that x cannot be equal to x cannot be equal to positive 1 rather, or positive 2, or positive 3. And there we go for the first one. Now, for the second one, I'll remind you that a negative exponent, for example, x to the negative 2 means 1 over x squared. Likewise, y to the negative 2 is 1 over y squared, right? So applying those exponent laws into this one, we're going to start with the numerator of, that's 1 over x squared minus 1 over y squared, okay? And those are over the product of x to the negative 1 times y to the negative 1, meaning 1 over x times 1 over y, okay? Now, I'm going to continue that over here. In the main numerator, let's say, we have the subtraction of two fractions. So we need a common denominator for these two terms, right? That common denominator is going to be x squared times y squared. And so we have to multiply this first term by y squared over y squared, and the second term by x squared over x squared to get a common denominator. And so that'll mean 1 times y squared is y squared, minus 1 times x squared is x squared, and we can write those over a common denominator because we did this in the process of acquiring a common denominator, that is x squared, y squared. Y squared, x squared is the same thing as x squared, y squared, and so I'll write it in alphabetical order, which is typically the convention we use. Now, all of this is still over the product of 1 over x times 1 over y, which is simply 1 over xy. 1 times 1 is 1, x times y is xy, okay? Now, we have a fraction divided by another fraction, right? You learned a long time ago that we handle this by, instead of dividing, multiplying and taking the reciprocal of this bottom fraction, meaning we're going to have y squared minus x squared over x squared y squared multiplied by, we'll reciprocate that, xy over 1, okay? And we can see some factors canceling out here. We have an x over an x squared. One factor of x is going to cancel out from each. So that x is completely gone, and this x squared is now just x. Same thing goes for the y. One factor of y cancels out, so the squared y becomes just y by itself. And now all we have left is, in the numerator, we have y squared minus x squared. And in the denominator, we have x times y, and that is as far as we can go. We could also state our NPVs from the beginning. X nor y can be equal to 0. X, y cannot be equal to 0. And there we are. Those are our simplified expressions with our non-permissible values clearly stated. So I hope this helps, and thanks for watching.